Welcome to EDU World Space.
Okay, so this problem is really showing you first in the first part, letter A, how to draw a ray diagram to project the position of where an image will be relative to a converging lens, given the position of the object shown here as a arrow with a distance p from the lens and a focus point on the other side of the lens that's closer to the lens than the object is. First of all, it instructs us to draw a light ray parallel to the optical axis, and then once it hits the lens, it is bent and travels through the focal plane. Next, it instructs us, the problem does, to draw a line. Next, the problem instructs us to draw a line straight through the lens itself. And then where these two rays cross is the position of the image. Well, let's give this image a height of I and the object a height of O. And the distance between the image and the lens, we're going to set as the variable Q. We're trying to demonstrate 1 over P plus 1 over Q is equal to 1 over F. Well, how do we do that? Let's first notice that the angle here is the same as the angle here, and that this triangle that has a height of O, when compared in ratio to its base of F, is going to be equal to the triangle here with the height of I with the base of Q minus F. Okay, so we have another set of triangles we can use, and that is with the angle here and here are the same. We can identify that the height O over a base of P is going to be equal to the height I over a base of Q for this triangle. So from here, let's rewrite the equation in blue by sending this term over to this side, and we get O over F times Q minus F is equal to I. And now we can substitute I into this equation here. Okay, so what we get is O over P is equal to O over F with Q as well on the denominator times by Q minus F. And notice that the O's cancel out. And now we have 1 over P is equal to 1 over F minus 1 over Q. So at the moment we send this over to this side, we are left with the lens equation we were trying to solve earlier, which is this one. Now for part B, we want to demonstrate that when P is much larger than F, the position of the image, Q, approaches the position of the focal plane, F. So let's just draw a line to separate part A from part B, and times the lens equation by F to give us F over P plus F over Q is equal to 1. Well, this term, when P is large, approaches 0. in which we can pretty much neglect it and then just times the remaining part of the lens equation by q, and we're left with F equals Q.